Hello students, in this video we are going to study about another hydrocarbon, that is alkenes. So in this video we will be going to discuss the introduction part, isomerism and nomenclature of alkenes. As we are already familiar with alkenes, alkenes are the unsaturated hydrocarbons having at least one double bond. That you can see, this is the structure for ethene. So these two are representing the carbon, and there is a double bond between the two carbon, and each carbon is attached to two hydrogen. This is the structure of ethene. So here alkenes are that hydrocarbon which have at least one double bond. It should have at least one double bond, then it is called as alkenes. The general formula for alkene is CnH2n, where n is the number of carbon. So if the number of carbon is n, the number of hydrogen will be 2n. So let us make the different molecular formulas depending upon the number of carbon. If 2 carbon are there, then the molecular formula C2H4. If 3, C3H6. 4, C4H8. That is, the number of hydrogen is double than the number of carbon. Now when we look at the condensed form of these molecular formulas, it will be in this way. That is ethene, because there is only 2 carbon, therefore there is a multiple bond, double bond between the 2 carbon. But in propene 3 carbon, but here you can see that there is only a single double bond, that is between the first and second carbon, and between the second and third carbon there is a single bond. So that is why the definition we wrote for alkene, that is the unsaturated hydrocarbon having at least one double bond. It doesn't mean that all the carbon-carbon bond should be double. Only if a single double bond is there, then it comes in the category of alkenes. Next we have a molecule here, 1-butene. Now you can see there is a double bond between the first and second carbon. Therefore the word in the naming will be using 1-butene. 1 means the double bond is between the first and second carbon. Therefore we have to name it as 1-butene. Next 1-pentene. The double bond is between the first and second. So here the number 1 is representing that the double bond is between the first and second carbon. So if I am writing 2-butene, 2-butene means the double bond should be between the second and third carbon, then it comes 2-butene. So here the double bond position plays a very important role, that is 1-butene, 1-pentene, 1-hexene, 1-heptene, 1-octene. That means in all these cases double bond is between the first and second carbon. These alkenes are also called as olefins. Olefins means oil forming. Since the first member of alkene, that is ethene, which was found to form an oily liquid on the reaction with the chlorine, that's why it is generally named as olefins, that is oil forming. Now let us discuss the structure for alkenes. Here we are discussing the structure of the first member of this alkene family, that is ethene. Ethene having 2 carbon, and each carbon is sp2 hybridized. So we'll be representing, this is sp2 hybridized carbon, this one is sp2 hybridized carbon. As we have already learned the orbital picture of ethene, that is showing the sigma bonds only here. In this, sigma bond is only shown. Here ethene in that 2 carbon which is sp2 hybridized, and the hybrid orbitals, these 3 hybrid orbitals, from this 2 hybrid orbital is overlap with the 1s orbital of hydrogen, and one of the sp2 hybridized orbital of 1 carbon will overlap with the sp2 hybrid orbital of other carbon. So here there is a sigma bond formation, because here there is head to head overlapping, that's why sigma bond formation. Here also head to head overlapping, that is a sigma bond formation. Here, here, here. So we can say that there is head to head overlapping between the sp2 hybridized orbital of each carbon with it forms a overlap with the 1s orbital of hydrogen, therefore it forms a sigma bond. And sigma bond, one of the bond between the carbon is sigma bond. So this picture is showing the sigma bonds only, but we have learnt that if there is a double bond from this, one is sigma, one is pi. So the pi bond we can be discussing through this picture. In this the 4 hydrogen which is forming sigma bond with the carbon that we have made here. One of the orbital, that is unhybridized orbital of the carbon, that is actually undergoes sidewise overlapping. That is sidewise overlapping. We have learned the sidewise overlapping. So that or overlapping is result in the formation of pi bond. So that we can see very easily the pi bond, pi cloud which is formed here between the 2 carbon. So that is why we can say that ethene molecule have 2 carbon which are bonded by one bond is the sigma, the other one is pi bond. So this is what the structure formula for ethene. It is showing that the 2 carbon atoms here, that is bonded by multiple bond, that is double bond. One is the sigma bond, the other one is pi bond, and each carbon is bonded with 2 hydrogen. Now when we talk about the bond length here, because we know that the CC bond length, C double bond C bond length, when you compare here, because when the bond order increases, the bond length decreases. So here in compared to the CC single bond, when you compare the bond length of C double bonded, this bond length will be shorter. So here the bond length between the 2 carbon is 134 pm, and the bond length between the carbon and hydrogen, that is 110 pm, and the angle between this is 121.7 degree, and the angle between the 2 hydrogen here, it is 116.6 degree. So this is what the idea about the structure of ethene. So ethene molecule we can make in this way, that is 2 carbon, this is the 2 carbon that is bonded by double bond, that is one bond is pi, one bond is sigma, and there are 2 hydrogen. These hydrogen I can represent here. There are 2 hydrogen on each carbon. So here are the 2 hydrogen on this carbon, and because here there is one sigma bond and one pi bond, and this carbon is sp2 hybridized. So the geometry for this one is planar. So these having a planar geometry. Next we'll discuss about the isomerism. Isomerism we have already discussed, that is the molecule having same molecular formula but different structure formula or the geometrical the way spatial arrangement of the groups or the atoms. So alkenes show both the structural isomerism and geometrical isomerism. So let us discuss the alkenes isomerism in these, that is structural and geometrical isomerism. Let us take one example of alkene, that is but1ene, which can also be named as 1-butene, or we can name it as butene, because the position of first double bonded carbon, it is not necessary to mention in this one. So instead of writing but1ene, we can write this one as butene, or we can also name it as 1-butene. So it is representing this molecule. Here, because there is a double bond between the first and second carbon, so that is made here. Now what happened? Let us make one possibility here. Just change the position of double bond. Now when we make the double bond between the second and third carbon, now its name is changed to but2ene. Now this is called as but2ene. look at both the structure carefully. It have same number of carbon and same number of hydrogen, that is C4H8, C4H8. That means these two are the isomers. And because here the position of double bond is actually different, that's why its name is different. That is, this one is but 1-ene and this one is but 2-ene. So these having same molecular formula but different position of double bond, therefore this is so called as position isomers. So look at here, they have same molecular formula, they have same number of carbon in the main chain, but the difference is there in the position of double bond. That's why these are called as position isomers. Now let us make one more possibility here. But 1-ene, if we branch it, we'll get the structure in this way. When we branch one of the carbon from 4 carbon, when we branch one of the carbon in this way, and still here the double bond is kept on the first position. Now when you look at here, this is the main chain here, and here this one is the main chain. So in this second case, this one will be the substitute. So the name changed now, it become 2-methyl prop 1-ene. But the molecular formula is same, that is C4H8. So these are called as isomers. But which type of isomer it is? That is, just count the number of carbon in the main chain. Here there are 4 number of carbon, that is in this structure there are 4 number of carbon in the main chain, and here there is 3 carbon in the main chain. So here there is a difference in the number of carbon in the main chain. Therefore these isomers are called as chain isomers. We have already learned the definition for chain isomers. So these two can be called as chain isomers. That means having same molecular formula but different number of carbon in the main chain. Now we'll be going to discuss an geometrical isomerism. When we look at the two structures which is given here, A and B. Here letter X and Y are the any atom or any group. So generally we have represented here X and Y. Now when you look at the two structures here, you can find that both have same molecular formula, because both have 2 number of carbon and there are 2 number of X and there are 2 number of Y. So same molecular formula we can say. Here X and Y we have taken any group or atom, just we are representing by X and Y. Now what is the difference in this two structure? When you look at carefully here, in the first structure, when you make a line along the carbon-carbon double bond and just make the two separation between these. So what you can find here, on the same side, look at this side, there are same group, that X group are on the same side and Y is on the same, 2Y are on the same side. But when you make the line over this, at that time you can see here there is one X and here there is Y. Here Y, X. That means if the isomers of the type A, that is this type, in which the two identical atoms, that is the two identical atoms or groups lie on the same side of the double bond, that is this one, this is this X and this X. These are the two identical. Why it is identical? Because we have represented it by X. So the two identical atom or the group, it is lying on the same side of double bond, that you can see it is on the same side. Both the X are on the same side and here both the Y are on the same side of the double bond. So that isomer is called as cis isomer. So how easily you can find out which one is cis and trans? That better you make a line over this double bond. Whenever you have a molecule, just make a line over this carbon-carbon double bond and look at on the either side. So if it is same group, that is here the group X, same group are on the same side. Here also same group on the same side. At the time this is called as a cis isomer. And when you look at the second structure, here also we'll just make a line over this 2 carbon, and what we'll do here, we'll be finding out the groups here. This is X group and this one is X group. Same identical groups are on the opposite side that you can see in this molecule. That is the identical groups are on the opposite side. Here YY are on the opposite side. That's why in such case that isomer is called as trans isomer. Now read the definition. It will be clear now. What is cis isomer? The isomer in which two identical atoms or groups lie on the same side of the double bond is called as cis isomer. That is A1 is the cis isomer. But on the other hand, that is the B1 is shown here. In this type, the identical atoms or the groups are lying on the opposite side. That you can see XX are on the opposite side and YY are on the opposite side of the double bond. That is important. It should be opposite side of the double bond. Then it is called as trans isomer. So it is very important to learn the method to find out cis and trans. So the cis and trans isomers have the same structure, but they have different configuration. That is, the arrangement of atoms or groups in the space is different. So due to this different arrangement of atoms or groups in the space, these isomers differ in their properties like melting point, boiling point, dipole moment, solubility, etc. So these all get differ. Why they get differ? Because they have different configuration in the space. So such isomerism is called as a geometrical isomerism. So when we take an example of a cis but2-ene and trans but2-ene. Now look at here. We have now particular example is taken but2-ene. That means 4 carbon and the double bond is on the second carbon. This is the main chain. Select the main chain. This is the main chain. From this first carbon is this one, second this one, third and fourth. So the double bond is between the second and third. That's why it is named as but2-ene. Now here when you look at here in this, I told you make a line along the double bonded carbon, and you can side on the same groups are there on the same side. You can see both the methyl group are on the one side and here the hydrogen that is on the other side that you can see. So this identical atom or the group of atoms are along the same side of double bond. That's why it is called as cis. And look at the next case, the trans one, in which you can see hydrogen are opposite side, and what about the methyl group? Methyl group are also opposite. How you can see it is opposite? I told you just make a line over the double bonded carbon. Now you can see on this side there are different group and here also different. So that is called as trans but2-ene. So these two are the geometrical isomers, that is the cis form and trans form. So while naming also we'll name it as cis but2-ene and trans but2-ene. And when you look at the boiling point here, they have different boiling point. Since they have different configuration in the space, therefore they have different properties like boiling point. Even though they also shows the differences in the dipole moment, that value also you can see here, because here the CH3 group, that is you can see in the trans form, CH3 group are on the opposite side. So when you make the arrows for showing the bond dipole, so it will cancel each other's. So that's why what happened, it get a 0 value. But here this will not cancel. So here there is a value for mu, but here the value of mu is 0. So from this itself we can make it clear that even though they have same number of carbon, hydrogen, but still we can say that they have showing different properties like dipole moment, boiling point, solubility, etc. So this is what actually the geometrical isomerism. Next, we'll be doing some problems based on the geometrical isomerism. That is a problem number 13.10. Draw the cis and trans isomer of the following compound. Also write their IUPAC name. So here, what is actually given to us? The condensed formula is given to us. So we have to make it into the cis and trans form. So the first one that we can draw in this way. The first one, you can see 2 carbon are there and double bond is between the 2 carbon. So we can make 2 carbon, and on this carbon there is one hydrogen and one Cl. So in the cis form we can write the same atom or the identical atom or the group, we can make it on the same side. So just make a line over this. I told you, just make first you make the double bonded 2 carbons, make a line over it and just find it out what are the group it is attached here. That is 2 hydrogen are there and 2 Cl are there. So 2 hydrogen keep on the one side and 2 Cl on the other side. So what you can write, this one is cis, because identical groups are on the same side of the double bond. And when you want to make the trans form, just change it. You have to make it the identical one on the opposite side. That you can see this is on the opposite side. So if you want to check it which one is cis and trans, so just make a line over the identical groups. So it is on the same side of the double bond. It is 2 hydrogen are on the same side of the double bond. So before that you will make one line over this and you can see that the 2 identical one are on the same side. Look at the trans one, must make the line over this carbon double bonded carbon, and you can see that here the identical group are on the opposite side. Here also identical atom, that is hydrogen, is in the opposite side. That is, it is called as trans form, and the name you can give it as trans 1,2-dichloroethene. Next, second part of this one, this is also we can do in this one, C2H5CCH3 double bond CCH3C2. That means between the this 2 carbon we can have a one double bond here. So first you make the 2 carbon where there is one double bond. Now look at here what we have the groups here. C2H5 group is also there, CH3 is also there. So first you make the cis form. So CH3 on the same side, C2H5 on the same side. And when it is on the opposite side, then it is called as trans form. That you can see CH3, this is the CH3 is in the opposite side, and the other one C2H5 is on the opposite side. So that is a trans form. So it is very important question because you will be getting this type of question in the exam also. Next we'll be discussing about nomenclature. That is the IUPAC naming of alkenes. We have already learned different rules in the previous chapter. So just recall that rules, and better will be take some text problem in order to discuss IUPAC naming of alkenes. That is a problem number 13.7. Write the IUPAC name of the following compound. So here some structures are given, we have to name it. So first we'll take this one, first part of this. So here definitely the confusion comes that which one is the main chain. For selecting the main chain, you have to select the carbon in the continuous. The carbon should be continuous and it should include double bond in the main chain. So here definitely this is CH3. Here CH3 twice are there. Better you can expand it and you write CH3 like this. So which one is the main chain? That is, we can select the main chain including this methyl group. Like this we can select the main chain like this. We can select the main chain. So which one will be the substitute? This one will be the substitute, and here one methyl group is the substitute. Because here C2H5, this one 2 carbon is there. Therefore, we have to take this one in the main chain instead of methyl group. So here we have how many number of carbon in the main chain? Because 2 carbon is here. 3, 4, 5, 6, 7, 8, 9, 10. 10 number of carbons are there in the main chain. So definitely here double bonds are there. So we have to give priority to the double bond. So from both the sides just count in which way we'll be getting the minimum sum for the double bond. So that side we have to choose it. So when we choose it here and we'll give the position for the methyl group, that is methyl group. Here when you count it from this side, this is the first carbon, this is the second carbon, third, 4, 5, 6, 7, 8, 9, 10. So at the time one of the methyl group is on the second carbon, therefore we can use 2 methyl word. And on the 8th carbon, this is the 8th carbon on which methyl group is attached. So that is on the 8th carbon there is methyl group, on second carbon and on 8th carbon there is a methyl group. So instead of writing separately, what we can write here, that is 2,8-dimethyl, and the position of double bond, that is on the 3rd and 6th carbon, and that is 2 double bonds are there, therefore it is called as diene. So the name of this compound is 2,8-dimethyl 3,6-decadiene. Why we are using diene? Because 2 double bonds are there and the position is on the 3rd and 6th carbon, therefore it is called as 2,8-dimethyl 3,6-decadiene. Next structure is given here. It's a bond line structure. Better you can expand it by keeping carbon on this each tip and corners. You can keep carbon and you can see the double bond here. 1, 2, 3, 4 double bonds are there. So we'll be using the word tetraene. The primary suffix we can use tetraene, and it is important to mention the number or the position for the double bond, because this is the first carbon. Better we can number this one: first carbon, second, third, 4, 5, 6, 7, 8. So total 8 carbons are there. That's why the word root will be oct, and 4 double bonds are there, therefore tetraene. But what about the position of double bond? This one is between the first and second carbon, therefore we can use 1, comma. This one is on the between 3rd and 4th, that's why we can use 3. And this one is between 5 and 6, so we can use the number 5. And this one is between 7 and 8, therefore use the number 7. That means between 7 and 8, so we have to choose the number 7. So 1, 3, 5, 7. These are the position of double bond, and the word root is oct, and 4 double bonds are there, therefore tetraene. So what is the name for this one? 1, 3, 5, 7 octatetraene. Here tetra word is used because 4 double bonds are here, that you can see, count 4 double bonds are there, therefore it is written as tetraene. It can also be written as octa 1, 3, 5, 7 tetraene. This number you can also write here. Next, that is this compound. So here this is given in the bracket. See, this whole part is twice. So better you expand this one in this way. That is how you can expand this one. Here better you can expand here. This is CH2, CH2, CH3, and here CH2, CH2, CH3. Better you expand it. So at the time, but when you take this one as the longest chain, but at the time the double bond will not be included in the main chain. So in that case, we should not do in such a way. We have to include the double bond in the main chain. Therefore, its name comes 2N propyl pent 1ene. It comes the name because we have to take one of the group, that is CH2, CH2, CH3. This one you can take as a substitute, and this one can be taken as main chain. So in the main chain you can take this as a substitute, that is on the second position, because this one is first, second. On the second position there is one propyl group, so that is 2 propyl, N word because it's a straight chain, and pent 1-ene. Why? Because the number of carbon, when you count it here in the main chain, 1 2 3 4 5. Better I will write it once again clearly. That is, here in this, better you expand this one as CH2 CH2 CH3. So at the time, this one will be the main chain, and this one will be the substitute. This one will be the substitute. At the time, numbering you have to do, this one is the first carbon, second, third, 4, 5. Here now twice is not there because we have already written this group once again here, so twice will not be there. So in this case, the group, substitute group, that is, this one is a substitute group which is on the second carbon, and because it is a propyl group, therefore 2 propyl pent, because 5 carbon are there in the main chain and double bond is between the first and second carbon, therefore we have to use the number 1-ene, or instead of that we can also write pentene. Pent 1-ene or pentene can be written, because 1 it is not necessary to write. So that is the name for this. Next structure is this one. So the name of this one is 4-ethyl 2,6-dimethyl dec 4-ene. So all of you do this one, the numbering, and select the longest chain and find out why this naming is in this way. So all of you try this structure by yourself and find it out which side you have to number, from which side you have to start numbering. Select the longest chain, select the substitute, and check whether your answer will be this or not. So all of you do this by yourself. So all of you practice well on the nomenclature. So this is all about this video. Have a nice day.